So hello again. Sorry for that. I thought we still have enough time. Just finish this part. This BI is greater than BB. Anyway, let me just check if you guys are already in front of your computers. Just give me a thumbs up. All right, so great. Most of you are already here, and then there were 4 or 5 who didn't respond. Anyway, so again, going back to this, VI is greater than VB, which is if this is the case, then we could say that VO is equal to VB. So yes, this is true. And yeah, this is also correct with this one. However, this is not true anymore because if this is not true anymore if we have a non-ideal connection. Because in here, it's not VO is equal to VB anymore. So it will become VO is equal to VB plus VB. Okay, already. Since if this is non-ideal, then we have to consider now the voltage threshold of this diode right here. So it's now 2 plus, let's see, if it's a silicon diode, then it's 2.7. Okay. Anyway, so that's it for the positive half cycle. So again, if ever that you have questions, just let me know. And then during the negative half cycle, so we have here negative to positive, positive to negative, and then positive to negative, and then negative to positive. So all throughout, our voltages will make this diode a reverse bias connection. So as a result, you can just we can just simply remove this part right here. And then when it comes to reading of BO, okay, our only reading is this negative 5 volts right here. So all of it will flow on this VO right here. Okay, and then going back right here, still negative 5, since this one is an open circuit. Okay, so I hope we're clear with that one. And how did we get negative 5 volts during the negative half cycle? So clear. Okay, so if you have a question, again, just let me know, okay? All right, so let's now move on to example number 16. So the same example, but this time it's now a non-ideal. So this is what I'm talking about a while ago. So during the positive half cycle, so it's not VO is equal to VB anymore, but it's now VO is equal to VD plus VB, which is now equal to 0.7 plus 2, okay? So this plus right here, and then 0.7 right here. So that is the reading of our VO. Okay. So are we clear during the positive half cycle? Pumasok sa mata ko. All right. And during the negative half cycle, so that's still the same, even though this one now is a silicon. So we still have a reverse bias connection all throughout. So negative to positive, positive to negative, positive to negative, and then negative to positive. So as a result, our only reading is this VI right here. So all of it will flow on our VO connection, which is negative 5 volts. All right. So I hope we're clear with this one. And then example number 17, this one now is negative bias. Okay. So positive to positive to positive, and then negative to negative, and then negative to negative, and then positive to positive. So all throughout, this is a forward bias connection. But then again, there is only one flow of current, that will dominate this entire flow of circuit. One current. So which one is it, the V1 or V2? So same concept, of course. So whichever is the higher voltage, so that is the one that will dominate the entire flow of circuit. So we have here V1, okay, and VB is incorrect since that is lesser than our V1. So in here, we have here a positive to positive and then negative to negative. So this will make this one a forward bias connection. So as a result, there should be no output, okay, on this flow of current. I mean, on this circuit right here. But since we have this VB right here and then this diode right here, so we're going to have a reading on this VO. So what is that? That is this 2 volts right here. And then since this one is ideal, so it will stay as it is. Okay. So as a result, we have here reading of negative 2 volts. Okay, so are we clear on how did we get this negative 2 volts?
Yes, sir.
Okay, so maybe this is your first time encountering this one, but yeah, this is also possible. So as you guys can see, during the positive half cycle, we have a reading of negative something voltage, which is negative 2 volts. Okay, so in here, what happened here is this negative side was lifted, okay, into negative 2, and then there is another reading of negative voltage. So it's something like this. So during the positive half cycle, we have a reading of negative 2 volts. And then during the negative half cycle, we have another reading, like the negative, uh, whatever it's read as a negative voltage. And then the positive half cycle, we still have negative, and then the negative half cycle. So we have a complete clip positive half cycle, and then all of them goes to the negative half cycle. Okay, so there are also some cases like this. So don't get shocked if we have reading of negative 2 volts, even though we are still in a positive half cycle. All right, and then during the negative half cycle, so as a result, we have here negative 5 volts reading only, since negative to positive, positive to negative, negative to negative, and then positive to positive. So again, if you guys are going to compare this one, we can actually have two results in here. Like initially, okay, we have a reading of, so during the negative half cycle, okay, let's start with negative 1, negative 2, negative 3, negative 4, negative 5. So the first reading is, of course, this negative 2 volts right here. Okay, that is during when VI is lesser than VB. So that is a part where, say, up to negative 2 volts. Okay, but it didn't stop right here, because after that one, it will still have a reading. Okay, like right after uh negative 2 volts, so let's say negative 2.1 up to negative 5, because this will make this one a complete forward bias. So if it's a forward my bad, reverse bias instead, since negative to positive. So this will make this one reverse bias connection. So during that negative 3 to negative 5, we have a reverse bias connection. So this will become an open circuit. And then our voltage reading on this voltage output will become negative 5 volts. So initially, during when VI is lesser than VB, we have a reading of negative 2 volts, which is this one. But after that, we have another reading, which is negative 5 volts, okay, which is, of course, the final reading, since our VO is always equal to Vmax. Okay, so when we say VO, it's equal to the Vmax itself. Okay, so uh, that's a different scenario already if it says that what is the reading of VO if VI is lesser than VB. Okay, but if it wasn't mentioned on the question, then as always, VO is equal to your Vmax, or the maximum voltage reading, which is of course negative 5 volts. So are we clear on why we have the reading of negative 5 volts in here? What about the others? All right. So just in case that you're confused, again, we have a lot of uh, other websites there, a lot of other articles out there, a lot of uh, videos on YouTube's which you can find and then try to watch and then try to analyze and then try to seek more different examples. Okay, just to understand more why is it -5, etc., etc. Okay. So on example number 18, we have here non-ideal. So same example, but this one now is non-ideal. So positive to positive, negative to negative, and then negative to negative, positive to positive. So same scenario. So we will only have one flow of current. So whichever is the higher. So in here, this one is forward bias, yes, and this one is also forward bias. But again, there should be no you know collision of voltage. So there is only one that will dominate the entire flow current. So that is the B1 since 5 is greater than 2. So in here, we have a forward bias connection. So the only reading that we're going to have is this part right here. So we have here -2, and then we have here positive 0.7. So just simply add those two, we'll have -1.3. Okay, so how did I know the polarity or if it's negative 0.7 or positive 0.7? So just take a look on the polarity itself of the diode and then your voltage source. So in here we have say a reading from below to bottom. We have here -2, and then from here we have positive 0.7. Okay, and then when it comes to reading this part, so always reads the above call this one sign, okay, which is this one, so negative and then the positive. Okay, because if you do the other way around, of course you will get positive 1.3. Okay, but the correct reading of this one is the above polarity, which is this negative and then this positive right here. So -2 and then positive 0.7. So just add them and then you will get negative 1.3. Okay, so are we clear with this positive half cycle? All right. Okay. Okay. So during the negative half cycle, of course, this will become a reverse bias connection. Okay, so even though we have a forward bias connection right here, but V1 is greater than VB. So yeah, this is the same with my example a while ago wherein we're going to have two results. So initially we're going to have uh, negative 1.3. So that's the initial voltage output reading. But as time will goes by, it will be overlap or it will be call this one overwrite by this V1 right here, since this will become a reverse bias connection and all of our voltages will flow on this VO, which is completely negative 5 volts. So that is why we have a reading of negative 5 volts on this VO right here. Okay, so I hope we're clear with this one. So anyone who has a question up to this point or a clarification? Okay, so just let me know again if ever that you have a question. So moving on to, moving on to a parallel negative clipper or shunt negative clipper. So it's just the other way around of our positive parallel clipper. So in here during the positive clipper, of course, we have a reading, but during the negative half cycle, okay, we have a 0 volts reading. Okay, so without a further ado, let's move on to the possible scenarios wherein during the positive half cycle, so as always, VO is equal to VI. And then during the negative half cycle, we have this one. So if it's a positive bias, we'll just make this one positive. So in here, as always, DD is negative. Okay. And then during the negative bias, of course, we also have a negative VB. But then again, you can just simply disregard this one and then just analyze the circuit and then just apply a KVL and then you will get the correct answer, instead of memorizing those formulas. All right, so let's have the example. So let's start with non-ideal connection first. So positive to negative, negative to positive, negative to positive, positive to negative. So all throughout, this is a reverse bias connection. Okay, so as a result, this will become an open circuit and then all of our voltages will flow onto our PO. So that is why we have the reading of 5 volts in here. So are we clear? Oh,
Sure po, sir.
okay. And during the negative half cycle, oops, yeah, non-ideal. Non-ideal na ba tayo? Okay, so we don't have ideal connection, so we did go straight to a non-ideal. Anyway, so if it's ideal, then just simply make this one a 0 volts reading. Okay, and then during the negative half cycle, so negative to negative, positive to positive, and then this one is negative to positive, and then positive to negative. So nevertheless, this one is still a forward bias connection due to this V1 right here. And then since we have a forward bias connection, so our reading of VO is this entire path only. So we have negative 2 plus negative 0.7. Okay, so again, just consider those outer signages. Okay, and then you will get the correct signage and then the correct value of your voltage, which is negative 2.7. Okay, so are we clear with this one? Okay, so we're almost done. So the last one is a clipper dual, combination diode clipper. So in here there is only one fixed one fixed format or a representation pattern of a dual clipper. Okay, so what do I mean by that? Okay. So in case that this D1 was, how do I rotate this one? Rotate for vertical. So just in case this D1 became like that. Okay, so we cannot call this one as a dual clipper anymore because this one doesn't work as a dual clipper anymore rather. Okay, so a dual clipper has only one waveform. Okay, it just varies with its value, okay, of the peak voltage on the positive side and then the peak voltage of your negative side, okay, depending on the value of your VI and then your D1, of course, and then your VB1 and your D2 and then VB2. Okay, so just in case I change this one into something like this one is not a dual clipper anymore. Okay, because this will simply accept one flow of current, which is maybe a positive or maybe negative only. Okay, so we must have this fixed format or representation just to get this kind of uh, voltage output or waveform. Okay, and that's the reason why it's called combination because we have a reading in positive and then we have a reading in a negative half cycle. Okay, so the only thing that we can change in here is the value of VI, the value of your say your voltage thresholds, the value of your VB1 and VB2. Okay, and you can add more, of course. Like maybe you can have another voltage or bias voltage in here, so it's still possible. Okay, it will just maybe amplify or reduce your voltage reading. Okay, but anyway, so yeah, these are the possible scenarios, like positive half cycle, if we have VI is lesser than VD1 plus VB1, you will have this one as your formula. And vice versa, if we have VI is greater than VD1 plus VB1, then you can use this formula instead. So I will not explain this one for now, okay? So I will let you guys read this one, same with the negative half cycle. So I will just explain this one on the actual example. So with that, it's easier to understand and apply those certain formulas. So let's have this last example. Okay. All right. So in here we have 5 volts. Okay. And then one thing that we need to check is if it's enough to make this diodes a forward bias connection. And if it's enough, then you can now proceed with the computation. So you can now apply those formulas right here. Okay. But with that, let's analyze this one by one. So if it's a positive or during the positive half cycle, so during the positive half cycle, we have this flow of current, of course, and then we have positive to negative. So this will make this one a forward bias connection. Okay, and then on the other side, let's say some of the voltages will flow in here. So positive is connected to the negative. Okay, and then negative is connected to the positive side. So this will make this one a reverse bias connection. Okay, so as a result, supposedly, if there is only one and it's a reverse bias connection, our 5 volts will flow on this VO. But that is not the case in here. Okay, once we have a forward bias connection on this side right here, and then the other one is reverse bias, our reading of VO will be on this forward bias connection only. Okay, that is the call this one the path, okay, or the from this node to node that is being read by this VO. So in here, we have here a positive 2 volts plus 0.7. Okay, plus 0.7, plus 2, and then plus 0.7. So as a result, we have a reading of 2.7 volts. Okay. And then during the negative half cycle, okay, during the negative half cycle, so just change this one. Oops, lahat pala matatanggal. Anyway. So on the positive half cycle, we have 2.7 as our VO. And then the negative half cycle, so just change this one into negative and then just change this one into a positive. So we still have this flow of current. So negative to positive. Oops, yeah, negative to positive. This will make this one a reverse bias connection. Then of course it will go in here and it will pass through this silicon diode. So negative is connected to negative and then positive connected to the positive. So we now have here a forward bias connection. So again, as a result, our reading of our VO during the negative half cycle will be on this path. Okay, so we have here negative 4 plus negative 0.7. Yes?
Bukas yan.
Yes, Mr. Lawrence?
Bukas yan. Wait lang.
Okay, so I'll just mute him for now. Maybe he's talking to someone. All right, so anyway, so in here, going back to our solution, so we have negative 4 plus negative 0.7. Okay, we now have here a reading of negative 4.7 volts equal to our VO. Okay, so were you guys able to get this one for the positive half cycle and then the negative half cycle? Okay, so as you guys can see, okay, the value of VI doesn't matter at all, as long as it will, be able to make your diodes a forward bias connection. So the reading of your voltage outputs now depends on this bias voltage and then your voltage threshold. Okay, so during the positive half cycle, we have this reading, and then during the negative half cycle, we have this reading right here. Okay, so 2 volts and then 0.7, and then 4 volts and then 0.7. Okay, so even though this one is 500 volts, doesn't matter. Okay, so this one is still 2.7 volts, and this one is still negative 4.7 volts. Okay, so during the positive, we have 2.7. During the negative, we have negative 4.7. So here is the references, or the reference only, since there's only one. Okay, on where is my presentation came from. And yeah, that's it for this module. So any question or clarification up to this point? Okay, so what about the others? Yeah, that's okay, Mr. Lawrence. All right, so if you guys don't have a question anymore, then again, thank you guys for coming, and see you guys next meeting for the module 5, which is the clamper. Okay, so goodbye, and see you guys next meeting, and keep safe.
Thank you po, sir.
Thank you, sir.
Thank you, sir.
Bye.